Hey everybody, we're going to get started today. We're going to talk about performance testing, which is going to include your pressure testing. So let's get started. All right, so getting started on this, if you understand the basics, you pretty much have it under control. The pressure, if you remember correctly, is really close to temperature. So you can actually use these pressures to diagnose a possible fault, either compressor not working correctly. You could have a plugged AC system, a plugged, a condenser. You could have icing going on inside the evaporator. So there's all kinds of things it can do. So let's go ahead and get started. So performance testing is, the performance test provides information about the AC system or systems operating efficiency. The AC system high side and low pressures are measured, and the discharge temperature of the passenger compartment is measured. So basically, we're looking at the pressures on the high side and the low side, and then we're going to also go inside the car too, and we're going to actually take the temperature. So the temperature should be pretty cold. You want to have good, performance to make that cool enough for the customer. Now, granted, a lot of the systems have their limits, let's put it that way, because I have found in my experience that the fixed orifice systems do not perform as well as the expansion valve systems do. So that's something to take in consideration when you're doing your actual temperature testing, your pressure testing, and stuff like that too. All right, temperature testing is an effective way to confirm the actual charge level and to check for performance of the components. Heat load is very important for temperature testing to be successful. If ambient temperature is too low, the readings will not be in the correct range, which can lead to misdiagnosis. So basically, you are looking at the heat exchange, you might put it that way. And if it's outside temperatures like we've seen in the lab, when we're trying to evacuate systems, sometimes we have a problem with how long it takes the refrigerant to be evacuated out. This is very common. And charging sometimes could be a problem too when you get into the colder climates too. Well, performance and temperature drop tests are necessary to achieve a complete system check. Although the tests are similar, they are different. The performance test is used to ensure that the system is meeting its design criteria. This includes the compressor's ability to achieve specific suction and discharge pressures at various heat loads conditions. The temperature drop test places the system in the worst case situation, maximum load, to see if there is any hidden problems or out of range components, as well as the check correct charge levels. And I'm trying to make sure I give you everything. I'm reading my notes as we go along. So we're setting up the actual the vehicle to give the maximum of, let's put it this way, we're going to put that system under pressure. We want to see if that system can operate at the peak, the peak ability, let's put it that way. Like I said before, the expansion valve systems and the fixed orifice systems actually have differences and how they're constructed, and also they are different possibilities. Let's put it that way. So your temperature test, your vehicle operating temperature, you got to get it to operating temperature first. An engine at idle, all doors open. Okay, so you're just going to pull everything on and put it on max cold, the blower motor on high. And then when you get into performance testing the vehicle at operating temperature, the engine RPM set to specs, okay, doors set to specific and specs, and the AC set up to specs, and the blower set up to specs. So we're going to start moving these levers around. We may have doors open, we may have them closed, and we're going to actually also check and measure the condenser and the evaporator. Like I said, we're going to stress this system out to see what it can do. So we're going to measure temperature drop. We're going to actually measure the condenser temperatures. To get your little heat guns out, folks. And then we're going to check the evaporator temperature at the best we can. Sometimes they're hard to get to. And then also we're going to check the duct temperatures. We're going to actually check the center ducts. We're going to check out the side ducts. If we have something in the rear, we're going to check that out too. And then we're going to actually look at the high side and the low side and the duct temperatures too. This is a typical pressure chart. If the AC system pressure and duct temperature do not meet the specifications with the vehicle set to the testing parameters, record the high and the low pressure gauge readings. The following example suggests that the cause may be with the actually given gauge readings. These gauge readings are taken with the vehicle operating in this performance test modes. So we're looking at the chart. Okay, we're looking at the chart and we're looking at the temperatures, the air temperatures. We're looking at humidity outside. So again, remember, depending on the weather outside is what we're going to be struggling with. So if we're, we should have these temperatures on the actual low side, and the high side should be pretty close to here. And then we should see the center duct temperatures are right about here. Okay, so remember, ambient temperature is what it is outside right now. The humidity, we'll have to get out our Google app to find out what the humidity is. And then we're going to look at the low side, the high side, and this is where we're targeting. We should be pretty close to this. All right. So here is a gauge reading, low side and high side. It looks normal. It is pretty normal to depending on what the weather conditions are. But the outside temperature is warmer than it should be. A possible cause, air delivery problems. We may have a check for blend door arrangements. Adjustments and damage. An AC control problem, check for calibration, check for voltage, or vacuum sources. So looks normal, but look at this high side. Look how it's actually starting to peak over here. I'm almost betting on, because I don't see too much higher on this side, but I actually might be betting on a possible, depending on the temperature outside, we may have a condenser that's starting to get plugged up. So it looks normal, okay, but we may have a problem here. So here we actually see, a normal, but look at the high side. The high side is very, very low. So we have possible causes, maybe a low refrigerant charge, check for, we'll have to check for a leak. The fixed orifice inlet is restriction, or we may have a expansion valve that's not working, has a problem with it too. Then we need to perform a performance check, and then high side restriction performance tests, drop tests like that. So we're going to look at the temperatures to see what's going on. Here we have another one. This is actually shows the actual low side high and the high side low. I'm sorry, we're actually looking for low side and high side high. So both of them are high, excuse me. I'm going a little too fast on here on my notes. Possible causes, air and moisture in the system. Remember, we talked about, how important it was to evacuate properly before we charge up a system and bring it into an actual vacuum so we can take care of all that moisture that might be in there. Because again, you get moisture in there, which causes all kinds of problems. Also with air, if we have air in the system, it can cause the pressures to go all over the place. And then we might have refrigerant or oil overcharge, and that's a possibilities. You get some people with these little, you go to AutoZone or O'Reilly's or whatever, and you grab up that can, hey, more is better. So they'll try to shove more in there. And then we might have an airflow restriction through the condenser, go out there, and some easy ways to fix that kind of problem is go out there and look at the condenser, see if you got a bunch of paper stacked up against it, maybe some dirt, because a lot of our vehicles are put together so that they'll actually scoop up air to actually go across the condenser and the radiator to cool things down. Well, all that debris may be pushed up against that condenser. Remember, the condenser's in front of the radiator in most cases. So we want to look to see if we have any kind of airflow problems, is what I'm trying to get into. So we may have an airflow problem against the condenser. Now, I'm really concerned about how high these pressures are, because eventually you'll start the compressor is going to try to try to overwork, and then it'll start blowing off on the pressure valves, or you might even have a hose actually pop off with it because of this high pressure. If it has any weak spots, it'll find a way. So you really need to do a really good visual inspection, and then if maybe we have a fan that coming on too. That's another possibility. But if it's restricted, you can take a nice garden hose and clear it off. You want to go reverse on it. You don't want to do the airflow side. You want to kind of take the radiator mounts loose a little bit and go from you look at the airflow coming in, and then you want to go the opposite direction with the garden hose. You don't want to pressure hose it, because you can actually cause some damage to the fins. I tend to like to just use, if I can scrape some of it away, don't take a broom to it or anything like that, because again, you can damage the fins. You want to just take a garden hose and push whatever other debris of that direction. So we can also have bad expansion valve. There's all kinds of things it could be, but I'm just giving you some of the basic stuff right now. Okay, on to the low side high and the high side low. This tells me right off the top of my head that we have an internal compressor fault. This may be in the variable type compressors that it has a valve problem. So we want to check to see if we have the control problem in our actual variable compressors, or if we have maybe in some of the older style compressors, we have a reed valve that's actually sticking, and it's not allowing it to allow it to go into the suction side of the compression stroke and then pressure it up. So it might be bleeding off, is what I'm trying to get at. So test setups, engine idling at normal operating temperature, all doors open, AC controls at max, and the recirculation mode, air selection, and then full cold for temperature selection and maximum blower speed. So when the AC system fails to meet the performance standards, temperature testing will provide additional information to help you find the root cause. This is the vehicle setup for a temperature drop test. So the condenser inlet to the outlet temp difference, 20 degrees of Fahrenheit max, 50 degrees minimum, I'm sorry, and then 50 degrees Fahrenheit max. Evaporator inlet to outlet temperature range plus or minus 5 degrees, zero difference ideal. The duct air temperature ambient should be about 30 degrees Fahrenheit minimum difference. So we're looking for what's expected. So always when you're diagnosing one of these problems, you want to say, okay, it should be this at that that temperature. So I'm taking my heat guns, I'm going all over the place looking to see a temperature drop. So it's your condenser, you should see some kind of temperature drop from the inlet to the outlet, or it's not working efficiently and you need to figure out what's going on. Your evaporator, same thing. It should be ideally putting out a certain temperature across it. And, you can't really get to these very easy, but you can actually check with pressure temperatures too, between the outlet and the pressure, the actual outlet temperature and the pressure temperature on the low side. And then the duct air to actually ambient air, 30 degrees at minimum difference. So we should be seeing a pretty good temperature coming out of the actual ducting. And look at that center. We should be having a good one. We shouldn't have too much spacing of temperatures. Okay. And so based on multiple vehicle studies, temperature test values are consistent for fixed orifice equipped vehicles when the vehicle is tested to follow, tested following this recommended setup. When performing temperature testing on the expansion valve equipment, vehicle evaporator inlet and outlet tests are not performed. So we're checking on the fixed orifice systems different than we're actually testing the actual expansion valve systems. Like I said before, there's some difference. There is difference between the two systems and how they operate. You need to know that before you go in. Remember, I said these are the expected temperature readings, and you have to take into consideration the fixed orifice difference of the expansion valve systems. The callouts show that the location is in the actual, fixed orifice tube systems where the temperature readings should be taken. It is recommended they be no more than 4 inches from the body of the condenser. So you don't want to get right up on it. You want to get too close to it. The evaporator reading should be taken close to the evaporator body as possible. The duct temperature should be taken at the vent as close to the evaporator as possible. Hoses and lines should have a 4 degree Fahrenheit maximum difference from end to end. Muffler assembly should have a maximum of 10 degrees Fahrenheit drop from the inlet side and to the outlet side. Here is a test points when performing the temperature testing on the fixed orifice systems. The two main checks here are the condenser inlet and outlet ambient to the duct. With fixed orifice systems, the condenser temperature test is the most telling of the state of charge in the system. So like I said, I always like to do a actual temperature drop between the when I'm looking at the inlet of the condenser to the outlet of the condenser. So remember, that is why they call it condenser. We're actually taking and we're cooling it off, which is going to actually cause it to actually condense the liquid, or condense it to a high pressure liquid. See, so we're looking at a chart right here. So this chart indicates possible causes if the condenser temperature reading is out of range. Inlet to outlet temperature more than 50 degrees, system overcharged, excessive air in the system, the condenser tubes plugged, inlet to outlet temperatures less than 20 degrees, system overcharged, condenser fan, air fins plugged, airflow problems like air dams damaged, or the missing. We have a cooling fan not working properly, debris between the actual condenser and the actual fan itself. For evaporator readings, outlet tube is more than 5 degrees warmer than the inlet tube. System overcharge, excessive oil charge, restricted orifice tubes. The outlet pipe is more than 5 degrees cooler than the inlet tube. System overcharge, or we have an orifice tube O-ring is not sealing. So when it goes down inside, it should be sealing pretty closely. And then we have the duct temperatures readings. Ambient to duct temperature is more than 30 degrees Fahrenheit. System charge is correct. The blend door is sealing, and the evaporator fins are clean. Ambient temperature to less than 30 degrees Fahrenheit. System charge may not be correct. Blend door faulty. We have an evaporator internal restriction, the excessive oil in the system, air in the system, outlet air duct, the door faulty, and the evaporator air fins plugged. Now, just really quick, I kind of got that off centered a little bit, but I do my best here. So some performance check issues. Leak, always test the entire system. The air in the AC system, use refrigerant analyzer, which we do all the time before we actually take any refrigerant out. Excessive pressure and temperature, check for airflow and cooling system. Poor connections, torque to correct values, use the backup wrench. And then lines or hoses restricted, check for delamination and buildup in filters. Excessive oil in the system, replace the filter, dryer, flush the system out, and add the proper charge. Non-compliant additives, check for sealants, and there's a sealant tester that you can use too, and any kind of enhancers that you may want to put in there also. So contamination problems, air, increased pressure oxidizes the oil, and dirt clogs control valves, causes abrasions. The moisture causes valves to freeze, and then causes corrosion and acids. Like I've said before, when you get the moisture and the refrigerant, sometimes it can turn into an acid. Debris, rubber and metal shavings, clogs, and damaged components. Residue cleaning, solution solvents, break down oil, and reduce lubrication. So you got to be very careful what you use to flush the system out. Wrong oil reduces lubrication, forms sludge, and actually it can attack the refrigerant. And you get really bad stuff in there. You can actually cause it almost looks like little balls. If you take like a mineral oil and use it in an R134A system, it can actually cause damage to the compressor and stuff like that too. So The compressor malfunctions, this is one of the things that can happen with your pressures, because if it's not doing its job properly, we can have issues with pressures. So let's look at how the AC system components can fail. Compressor malfunction will include noise, lockup, leaking, low suction, and or discharge pressures be wrong. And then noise can be caused by loose or missing hardware, or caused by internal compressor damage, including broken reed plates, worn bearings, or piston damage. Lockups can be caused by leaks and restrictions in the axle system, or control device malfunction. Leaking can occur at the shaft and seal center joints, or in the head assembly itself. So I'm looking at this picture right now, and I can actually tell you right now, this has really been hot. It looks like it's, you've been slipping, possibly, and causing heat. But the other things I really look at is your pressures. And when you can start seeing the pressure of, when you start seeing compressor faults in the reed valve area, you're going to see bouncing, really drastic bouncing, and a little bit sometimes too, in your actual pressures. You'll see that where it's not actually sealing properly. So you can have stuff like that. You can have bearing noises. You can have leaks from either the hoses, the head assembly. You can actually have leaks out of the center, the valve, center seal of the actual compressor too. So there's all kinds of things that can, and you usually find this kind of stuff when you get into your older systems. But keep an eye out, always do your leak checks before you go too much farther. The correct charge will actually, see things like this. Now, the other thing too, I wanted to bring across too, is if you get an overcharged system, your pressure is going to be pretty high, and it's going to put a lot of pressure on the actual compressor, and it's going to try to do its best. And you might even, to move stuff around, you might even hear some knocking noise. You put too much in, and it's, instead of being at a gas state, it's going to be at a liquid state. And you know that, you just from general mechanical knowledge, that you can't compress a liquid. You can only compress a gas. And if it's at a liquid state coming out of the evaporator going into the compressor, then you're going to actually cause damage to that compressor too, and all the internal parts of it also. So condenser problems are either caused by leaks, restrictions, or damage. Leaks can be caused by internal or external corrosion from road salts and other environmental pollutants. Leaks can also be caused by loose or broken mounting hardware. So just like your compressors, you want to make sure everything's bolted up and everything's in place like it should be, because you can get that knocking noise from it just bouncing around. Also, with your condensers, you can actually cause faults from the compressor by not having it mounted properly. It has these rubber mounts to it. It has hard mounts, usually on the top, or it might have a rubber mount on the top too. That's to keep out any kind of vibration that might damage it. And if you've had front, car damage where it's been hit, a lot of times that condenser's up front, and that's the one that takes the first hit. And you can have damage that way. You can just get a rock off the road, and they actually hit one of the fins, and you actually cause a leak that way too. So right now I'm looking at a lot of road debris right here. Not as bad as what I've seen, but here again, you want to make sure this is cleared out. Again, just take the garden hose from the backside here. You might have to take the radiator and push it forward a little bit, but you can clear out a lot of this just by doing that. That's kind of a little tips along the way. Now, this is one of the things, if you look at the fixed orifice tubes, if you take them out to inspect them, you can see a lot of what's going on. If you see a lot of rubber pieces, metal flakings and stuff like that, that tells you right there that compressor is probably getting ready to go. So you want to address that, or you're going to have, it's not going to get better, was what I'm trying to say. It's just going to get worse. And one other tips too, I want to give you too, they are color coded, and do not put the wrong fixed orifice in the system unless you have a technical service bulletin saying, hey, we've got this new updated fixed orifice for the system. Exchange the old one out for this one, then that's cool. But always look at your fixed orifice. It'll tell you a lot of what's going on. On your expansion valves, it can get clogged. The sensing bulb, it can't maybe loosen the refrigerant charge. That little bulb there, that actually isn't positioned in one of the lines, and you want to make sure it is tightened down correctly. Usually there's a set of clamps that you clamp it down with, or it clips into. It has to be in contact with a evaporator line, and then they usually have a wrapping going around it to kind of isolate it from the inside temperature, so we can actually get a very good temperature rating of what's going on. So you definitely want to make sure that it's not damage, of course, any part of that tube. Sometimes you'll have an additional tube off of it too that actually just goes right into the evaporator itself. It doesn't sound like it could happen, but the evaporators can get clogged, especially on the old systems where we had no filter in place. These can get debris in place, and it is a pain to try to, you have to take the whole dash out to get it out so you can actually clean it up, which with the new filter systems, which you have the filter in place in the direction of airflow, it causes, that won't be as bad. The other problem I've seen, and actually I've seen it happen, let's put it that way. Some people don't know there is an extra filter that's just for the air conditioning. That filter is to keep a lot of the debris from the road from coming in and you breathing it. And the old systems didn't have this. The new systems do. So you think about it, just like the condenser, we had airflow going across that, it could get plugged up. Same thing with the older evaporators. Not so much now compared to what it was back when, but now we have another thing we have to educate our customers about too. There's a filter in place, and that's what the job is, to make sure you don't get that air, that dirty air inside the actual passenger compartment. So this is something that I've seen totally plugged up. I mean, it almost looks like an air filter that you probably serviced sometime along the way. This guy gets so packed that now it can't get the airflow going across. I had an actual, I'll share a little story with you really quick. Like I had a friend, her friend's car, her friend was complaining about, man, the blower fan doesn't work and it doesn't get very cool in here. I don't think my air conditioning working. So she brought it to me to have it checked out. And I just did some basic stuff. I'm like, man, we got nothing going on here. So I went into the glove box, and that's where the filter was at. I pulled it out, and I could barely pull it out. I actually had to get a bag, and just a plastic bag to actually take, and I had to kind of move it back and forth and almost force it out to get it out. But then I had to take a vacuum and clean up all the ducting area, because there was so much debris inside there that I couldn't get that filter out. And then when I pulled it completely out, it was completely plugged. And I showed it to her and said, I think this is your problem. So I went down to the local AutoZone and picked up one. They make them all kinds of different flavors, as I call it. And you can actually get some Febreze ones, some different scents to be inside the car too, which it does wear out after a period of time, of course. But I changed it, and I put it back together and turned it back on, and wow, it was a total difference. And it started to cool properly. I did have to kind of garden hose the condenser too, but these are just some basic steps that you can do, and sometimes they cure your problem. So like always, when you're diagnosing and you're looking at things, always try to go for the basics first before you actually dive in and put on the scan tools or actually get the hoses connected to the system. You want to look over the basics first before you go to the next step. And then both there's a filter inside in the in accumulators, and there's a filter inside, well, I should say a condensate bag, not really, there is a filter, but not as, is like some of the filters in your the systems you might see too. But we have both the actual accumulator and the receiver dryers have a desiccant bag inside. That desiccant bag is there to take moisture out of the system. It's not there to take an extra amount of moisture. So if you're just opening the system and leaving it open and then closing it, days later, you may have too much moisture in that desiccant bag. And then that desiccant bag can't do its job. So you're going to end up changing the accumulator or the receiver dryer. And then you're going to have to take all that moisture out of the system too, because now it's overpopulated and it's going to go through the whole system. And what did I say about moisture in the refrigerant? It can actually cause an acid to start eating away at things. So your refrigerant lines, of course, you want to see if there's any kind of leaks or any kind of damage to the refrigerant lines. You can, my dad used to do this too. He used to just touch the refrigerant lines and say, okay, this one's working great and this one's not working great. But there is a temperature drop, of course, of the lines, but you want to check for leaks and you want to check for any kind of damage across the way. But if you start getting some strange pressure readings, you can actually go through with a temp gun or actually go and touch the lines. You can actually ID if there's actually any kind of a plug up system along the way too. So not enough refrigerant, could be a problem. Any loss, the amount of refrigerant will reduce the amount of ability to cool and dehumidify the actual compartment. The reduced charge also affects the actual, hey, how does the oil get transported? It gets transported through the actual refrigerant. So we need to be able to circulate it around. And if it doesn't do that, then it's actually going to be a problem, with the refrigerant low, and then it's not getting the oil around to where it needs to go. And then, of course, we can have compressor control issues, and this is again your HVAC systems now are all electronic, they're automatic, and we could have an electrical problem that way too. And also, always look for service information. There might be some updates on the refrigerant charge. Like I said earlier, the fixed orifice, tube. It could be a new expansion valve involved in it. So there's so many things that can actually help you along the way. So this is really getting into the performance side, which we're also talking about pressure readings. I hope this was beneficial. If it was, please leave me a comment. And if you like it, you can actually like it and subscribe to what I'm talking about. And I'll be putting up more videos as each week. Let's put it that way. I'll probably put 1 or 2 each week, and they'll actually cover a lot on the automotive side, air conditioning side, performance side, brake side, all kinds of stuff out there. So if you know how to get a hold of me, so go ahead and email me, give me a call. And if you find anything you would like me to make a video of, put a comment down below and I'll do my best to help you out. Bye for now. Catch you next time.